Let's hop in and get started. Good afternoon, and thank you everybody for joining ThreatX's live Q&A, talking with our API experts, Austin and Alex, about how your engineering and security teams can work together to improve your organization's API risk exposure. Over the next 30 minutes, we're going to cover both sides of the house on how to ensure protection for your APIs, how to improve awareness of your attack surface, and ultimately how to best manage it. Now, we've purposely built this webinar to be as interactive as possible, emphasizing on the live Q&A portion of this session. So we'll be stopping along the way, answering some of those questions that are populated in the Q&A. Don't be shy to share them, and we'll also be posting some polls to keep this as interactive as possible. So with that, let's hop on in and we'll introduce our experts. So today, helping me out on our session is Alex Gatz. He's our lead analyst in the ThreatX SOC. He's skilled in pen testing, software engineering, reverse engineering, and malware analysis. Really, the list goes on and on. But Alex today drives red and blue team exercises for the SOC. He automates SOC operations and is constantly writing and fine-tuning new detection rules for our customers in zero-day vulnerabilities. So Alex, if you want to hop on and say hi, feel free to.
Hi, everybody. Really glad to have you here. Really excited about this.
Awesome. Next, we have Austin Jones, who is our tenured principal software engineer here at ThreatX, who's focused on API and application security. He's designed and implemented our API discovery algorithms for various protocols like REST, GraphQL, gRPC, and constantly does rapid prototyping on awesome new innovation projects. So Austin, again, hop in and say hi.
Everybody, thanks for joining.
Awesome. Lastly, my name is Cindy Cafaro. I'm a product expert focused in cybersecurity solutions over the past 10 years in API, application security, SOAR, and incident response. And today, we're really excited to talk to you a little bit about API security, multi-mode attacks, and to share with you our tips and tricks along the way. Now, the first place we're going to go ahead and get started today is one of our most frequently asked questions, which ultimately is, what is API security? And for those that are familiar with the buzz in the space, API security has been a really hot emerging market in cyber. And a really important thing to emphasize as to why is because APIs have become widely adopted over the past few decades as a main way to share and access data between various applications and application services. The data shown here only emphasizes this growth in API adoption, but it also emphasizes the growth in API attack surfaces along with it. And with that, introduces our problem, which is that really these attack surfaces are getting increasingly harder to manage on the security side of things. Now, a few examples to prove how API security is affecting every sector, even the most technological leaders like Facebook and Venmo can even be exploited. Now, I realize that a live Q&A can somewhat be nerve-wracking, so to really help us ease into it, I'm going to start off by launching a poll and just asking everybody, how has API abuse or seeing API abuse in your environment been relevant to you? So I just went ahead and shared that, but Austin, Alex, curious to pick your brains on this as well. Is there any additional details you guys would like to add as far as the data breaches that we kind of just highlighted here?
Yeah, so I think one of the things that's really changed over the past 10 years is just the amount of data that's available and just the vast difference in size of the API surface. There's been a big shift towards public APIs, and SaaS became really popular about 10 years ago, and as a result, cloud vendors have huge API surfaces, and and basically any product is going to have some kind of API surface. So it's not surprising that data breaches are have become more common with that because there's so much more to protect.
Yeah, absolutely. It's really like from the security side, it's just really hard to get like really clear visibility into, what the developers are working on and what's, maybe being forgotten about or left behind. And it's I think the key there is really just the inventory management. It's really hard to keep track of this like ever growing list of an inventory of every possible endpoint that's out there.
Awesome.
Yeah.
Thanks, guys, for weighing in on this. And I'll go ahead and share our poll results. I think these results only emphasize something that we're going to touch on shortly, which is that, a healthy mix of all these different attack vectors, credential stuffing, account takeover, API abuse, are all being seen in the wild. So with that, we'll move over into our next topic, which really, now that we've talked a little bit about API security, the emerging market, and how really everybody with a virtual presence can probably resonate with API abuse. I'm going to pass it over to Austin and Alex to talk a little bit about what's being seen from the wild on both sides of the house with API engineering and API security.
So yeah, I'll get started just talking a little bit about technology and the shift that's happened over the 10 years that I think really explains why API security is important now, or at least a good part of it. So if you look back about 20 years, web applications were much simpler than they are now. They're also much less common to have, rich, dynamic kind of applications. And back then in the 90s, it was really like a lot of static HTML pages and some PHP web apps. A couple sort of small, web apps that if you took a look at the code probably weren't too complicated. You could probably read them, and get through them and, grok them pretty quickly. And PHP had tons of security problems, and a lot of the programming tools that were out there had, rampant cross-site scripting and SQL injection. It was almost impossible to write code that wasn't full of those things, which has dramatically improved. Now, most frameworks are pretty much secure by default. It's really hard to write SQL injection or XSS. But then around the 2000s, REST and JSON started to become popular. And what that really allowed was basically the start of APIs, right? I had to take a problem. I want to have one system call another and talk to another, and one system's going to store data, and another system's going to use that access to that data or the ability to write that data to provide value. And that became, the technologies that were necessary for that to happen really came into play in the 2000s and grew and grew and grew until more complex federations started to become common. Like OAuth started the Federation of Authorization, right? So like social logins and more subtle uses of authorization happened, and systems started to become more and more interconnected. And a lot more of the systems started to be public. Of course, you're going to require a user account, but probably if you looked in the 90s, a lot of those APIs would have been private behind a firewall and not accessible to anybody, which has really upped the requirements for security for the things that are public, because you need to make sure that, basically it's safe for anybody to interact with, or at least you've gotten through enough of the problems that nobody's going to find the one or two things that you didn't think of to find, and so about eight years ago or so, there's this huge explosion in API technology. So that's the last thing here of 2012 to 2016, where OAuth 2.0 came out, OpenID Connect, another authorization federation standard, GraphQL and gRPC, and way more that I couldn't fit. But just like there's this huge explosion in API technology, and so where we're at now is all those technologies have been out there, and there's tons of applications that are based on them. And so API security, I think, is relevant because there are just lots of APIs. There are a lot of them, and they have a lot of endpoints, and they have a lot of parameters, and just there's so much to protect. And so, yeah, that's I think the nutshell of where API security came from, and why we're all here.
Awesome. Thanks, Austin, for walking us through really that proliferation of APIs, how they've differentiated through the time periods. Do you want to ask a question that's popped up in our Q&A? Again, guys, don't be shy to post questions. But thank you to whoever posted this, Austin, Alex. Do reverse proxies provide any protection against API-based attacks? Like, for an example, could you explain the benefits of your solution versus like a pfSense or a Squid solution?
Yeah, absolutely.
Yeah, go ahead,
I could
Alex.
kick off that one a little bit. I will say I'm not very familiar with Squid or pfSense. I do not have direct experience with that. But to answer the first question, do reverse proxies provide any protection against API-based attacks? Simply yes, they absolutely do. And I think the key there is by being a reverse proxy, you have a combination of benefits. So I think the first most obvious one is it completely hides your backend technology. It's really hard to tell what tech stack you have behind a reverse proxy. That's first and foremost the one of the best things that you can do with that. I think secondarily, since we're handling that traffic in real time, that allows us to take very aggressive direct decisions, such as real-time blocking for any type of API-based attacks. I think another great thing about having a reverse proxy as a solution is it can be very lightweight and very versatile. We can move our solution into just about any architecture. So that's definitely a really powerful thing that we're able to do. And with that, it's a highly performant solution as well. I don't know, Austin, do you have any additions there, or if you use Squid or pfSense at all?
Yeah, I can elaborate a little bit on the real-time blocking stuff. So one of the things that we've seen recently that's becoming much more common is huge distributed attacks. So attacks that are coming from, I think we're going to get into this in a minute, but like just an enormous number of IPs, millions of IPs. And when you're dealing with that kind of scale, anything that's based on recognizing an IP and blocking that IP starts to break down, because an attacker really will just move on to the next one, and they'll tune their scripts so that they get enough requests through that they don't get blocked. And if they get blocked, they'll just send fewer requests, send fewer attempts. And so one of the things that I think is really important in API security platform is the ability to work at the request level and also work at the entity level, and combine those things together. So that if somebody is staying on one IP, you can catch them. And if they're moving around, you can start to figure out what exactly they're doing and catch them as after they've moved to the next IP. And it's challenging to combine those things together. And it's challenging to get a rule engine to work really well, and some intelligent sort of risk aggregation, entity correlation stuff. But if you can do that, then you have so much flexibility to respond to an attack by recognizing the attack, or respond to the attack by recognizing the specific entity, the specific threat actor.
Awesome. Thanks, Austin, for walking us through that. And I know that you mentioned, the importance of calling out, what we're seeing in the wild as far as the distributed credential stuffing attacks, which I think brings us to our next point of, defending APIs can't just be defined by some of the regulations that we're seeing out in the market. One, for an example, that's really hot in API security is OWASP top 10. Alex, any additional detail, or even Austin, that you'd want to add in for this side of things?
Yeah, absolutely. So I think the biggest thing, like the biggest point I wanted to make here is just that, yes, of course, attackers are going to focus on the OWASP top 10, but please don't forget that they will do things that are completely not on the OWASP top 10. So if your primary focus is looking for a solution or like protection technology that's solely focused on the OWASP top 10, an attacker really doesn't care about the OWASP top 10. They're going to try literally anything. They have time on their side. They're going to be slowly poking away at your applications until something works. One big thing, and Allison actually started to touch on, is these monstrous distributed attacks. We've been seeing millions of IPs in coordination to do credential stuffing attacks. Not hundreds, not thousands, millions of IPs sending one login attempt and then they might not try another login attempt from that same IP for 30 minutes, 45 minutes, an hour. Maybe they don't try it at all. So it gets really tricky. And I mean, it's really difficult to try to block something like that. Historically, you might use a rule that's looking at like 400 codes and maybe trying to count those in a certain amount of time. And yes, that absolutely does work if the same IP is firing off an attack at the same time. And Sydney brought up our dashboard here. I think that's great because it showcases 20 million requests were blocked. That's that first blue hump you see. That was 20 million requests that were blocked. This was an actual attack that happened just recently that we pulled this from. So 20 million requests were blocked. I know I've said that 3 times now, but it's just it was mind blowing to see, and we keep seeing this more and more, and we're seeing it across various login endpoints. We're seeing it across credit unions. We're seeing it across SaaS solutions, anything you can imagine. Not just one vertical. It's a good number of verticals, and it's alarming. Honestly, it's daunting. I mean, you're doing big data analysis to try to break down what you're actually seeing and try to find like differentiating factors there that you can key off of if you were going to solely focus on a single rule to block this. Another big one is 0 days. So the OWASP obviously can't account, since it's kind of looking back at that past year or maybe a past couple years and kind of looking at like the frequency of attacks over that time. It can't really account for 0 days. And I think Log4j and Psychic Signatures just recently was a great example of that. Nothing like that has really been seen before. And anytime you're targeting a platform that's so widely used, it's going to have a monstrous impact. I can't tell, like Log4j getting scored as a 10 CVSS 3 score. I mean, that was just shocking. It wasn't, I mean, we did see it coming. It wasn't, completely like we were blindsided with it, but just shocking that when the score dropped, it was truly a 10. It was cool. It was not good, but it was cool to see.
Yeah, when I first heard about Log4j, I was like, this seems really bad. And then the next day I was like, this is really bad. And the next day it just kept going up for me of just like realizing, the impact that it had and how trivial it was to exploit, and how many systems were out there that could potentially be exploited. And it was but it I think one thing that OWASP Top 10 is good at is saying, how do we look at software we have and look for problems in it, but it's not the total package of here's the things you need to be doing, because it doesn't really account for dependencies. It doesn't account for sort of attacker behavior. It's not a list of recipes that attackers use. It's a list of things that you can look for in your software that will make it harder to attack. And so it's valuable from that perspective, but if you assume that attackers only do OWASP Top 10, you'll be very surprised when you start looking at real prod data.
Yeah, I think that's a painful lesson to learn for a number of people, to be completely honest.
Awesome. No, appreciate you guys walking through really like you said, Austin, how important it is to highlight the dependencies. And even though we do have these industry best standards and best practices to follow, I think really, the cat and mouse game that is cybersecurity isn't just following the exact recipe, but it's also thinking outside of the box of what people aren't expecting. I'm going to move forward to talk a little bit more around real-time blocking, but we also have a question that just came in. Really quick, would one of you guys want to review like high level, how was our solution in line with API traffic?
Here, Austin, you want to take this one?
By inline, you mean like in the middle, like the proxy question? So our solution is a reverse proxy. And there's a lot of challenges with building a solution that's reverse proxy, just technically getting it started. But the reason why we chose to go that direction is that we started to think about how do we actually prevent malicious attacks from reaching a backend application. And our goal was really identify malicious requests, try to find as many ways as possible to identify them in a way that sort of will cover multiple angles. But if you're in line, you have the chance to block attacks. And I think in most cases, the impact of an attack payload is, moderate. Like if it contains a SQL injection attack or if it contains XSS. But there's some cases where an attack payload reaching an upstream server can be pretty extreme, So psychic signatures is one where, if somebody shows up with a psychic signature JWT token and just says, hey, I'm this other user and starts accessing things, that's something that happens very, very quickly and has pretty significant impact if it's exploited. So the reason why we decided to go with an inline solution is because we can literally just stop those things from moving on. We sort of think of it as we're the boundary, and you have everything that's sort of inside your inside your security perimeter behind us, and everything that's outside in front of us. And we can learn what those things are, try to figure out how to recognize them, and then just prevent them from moving on. And the security guarantee that provides, or the security advantage that provides, is that very, very quickly you can react to these kinds of things, and in our case, we build common rules and stuff and push them out. And then after that, those requests won't reach an upstream server, and they won't have the potential of getting in your logs if they're log4j or, so because a request is blocked, it means the attack payload doesn't move on, rather than just rather than cutting down the number of attacks,
Awesome. Yeah, no, for sure. And I guess, Alex, to build on that question.
We lost you.
Can you still hear me okay?
Oh, yeah,
just came back. Yeah.
Okay, sorry about that. Austin, to build on that, and Austin, thank you for the detail, is, if you could estimate, how long do you think it would take for us to identify and block an attack, since we are sitting in line?
A lot of attacks are instantly. I mean, there's not even, I would say, a good majority of attacks. If we're blocking something real time, we mean real time. It's as soon as we see it and we identify. I mean, we're identifying that it's bad in milliseconds. I mean, literal milliseconds.
Awesome. Thanks, Alex.
That's actually, we have a pretty tight performance budget because we're in line. It really matters that legitimate traffic gets forwarded as fast as possible.
Absolutely.
And if we were to add 10 to 15 milliseconds to each request, then your web app that's loading a bunch of JavaScript and some CSS and some images really would have an impact. So the catch with real-time blocking is you have to forward legitimate traffic really, really, really fast. It has to be essentially instant, to forward those along, because that whatever that cost is going to be added up, hundreds of times in the course of interaction of a regular user with a web app.
Okay, awesome. And that makes a whole lot of sense. And I think this also reinforces kind of some of the points here, which is that real-time blocking is a must, not only for, attacks that are reaching your APIs, but also to account for the potential vulnerabilities that may not have been remediated yet in your new applications, or applications, for an example, like Log4j, that are using open source software. Really, that real-time blocking is what's going to make the difference between data getting exploited versus not.
Yeah, without real time, it's too late, especially with Log4j.
Awesome. I think one of the biggest pieces that we want to make sure that we spend enough time on today is the tips and tricks along the way of really managing your awareness and, the attack surface management side of API security. And I think a lot of the tips and tricks that we're going to share with you guys now really center around collaboration between engineering and security. So I won't take too much of Alex, Austin, your fire here for your tips and tricks. So I'll let you take it away to kind of explain some of our learnings here.
Okay, absolutely. So let me just first say this is a lot of work. It's a lot of work to collaborate with the development team, the engineers. It's a lot of work for the development team to collaborate with you. As a security professional, you're interrupting their day, their focus, their time to ask them these deep questions around, how does this application work? Like, what is this application really doing? What are these endpoints for? what data types should these endpoints be using? And it's information a security team needs to know. You need to know what methods are being sent, and in that data structure, like in the JSON or in anything, like what data type should be allowed for a value. Should they allow a Boolean? Should it be an integer, an unsigned integer, a string? That's all information you need to know if you're going to make intelligent blocking decisions. And it doesn't scale well to try to reach out manually, or even, like I would love to just dig into the code, but in reality, it's going to take me a long time after you get past a handful of applications to try to really figure out what all these endpoints are doing and profiling those and trying to really deeply understand that. And like I was saying at the start, it's going to take the developers a lot of time to explain that to you, but it is a necessary evil. You do need to have some kind of inventory of these things. I'll pass it over to Austin. What do you think,
Yeah.
Austin?
So yeah, I've spent a lot of time answering those kinds of questions, and have gone through with security many times, trying to advance security initiatives, advance compliance stuff, and sometimes being like, this is too hard, this is too much. But I want to sort of dive into this third bullet point of how to interact with engineering. I mean, you are asking for people to spend their time to help you. And if you're asking them to also incorporate security into their SDLC, you're also asking them to spend extra time on all their future tasks. So I think in general, engineers are willing to try. But I think when it comes to effectively working with engineering, I think what's really important is just acknowledging that you're really asking for something. You're asking for a little bit of productivity. You're asking for them to go out of their way. The more you can do to help them with that, the smoother it can go. Like training, if you can teach people, just explain to them, hey, here's the security problem, and here's what we're trying to fix, and here's why it's so important. That really helps with people being like, oh, I think that I probably need to spend more time on this to get there. Yeah, I've actually had a lot of fun working with security people. And when I first got into security, it was just like this revolution of how I thought about software engineering, which I realized was missing and was sort of the original reason why I did it. But yeah, it's really important to go through that process and get to the point where you really understand what your applications are doing.
Yeah.
And the challenge with it is just as Alex mentioned, there's so much stuff. If you have 20 applications, it's hard, and if you have 200 applications, it's really, really hard.
Yeah, exponentially more difficult for sure.
Yeah.
Yeah, so I think some of the biggest takeaways that we can share with everybody in the call as it relates to awareness and management is first, when we're developing and documenting APIs, have a security mindset when you're developing those APIs. Do you have to incorporate this list of data, or is it best suited to only incorporate these 3 or 4 parameters that are actually required? Be aware of which endpoints are managing PII, managing PCI, managing really sensitive data, and being aware of where those lie and sharing that with security teams, as well as other application owners. One of the biggest pieces that we can't emphasize enough is adopting an inventory of your APIs. So actually keep documentation with an API schema specification, not only of your APIs, what type of API calls you should be expecting from that endpoint, but also like what parameters are normal, what's the normal behavior that should be seen there. And having that definition will significantly help security teams understand what is normal versus what is suspicious. On the management side of things, I think another thing to also really help with the ever-growing attack surface, right? Because as you put out new APIs and API versions, that attack surface is going to continue to expand. You can reduce that expansion by making sure that you have a formalized process for deprecating old APIs. And when you deprecate those APIs, make sure you update that specification. So again, if we see somebody's reaching out to an old API, that is now a suspicious behavior that would have been normal in the past. So making sure everything is updated. So again, people can call out what traffic is suspicious, what traffic is normal, is going to be hugely important when analyzing your API attack traffic. This is just an example of really how we analyze our API track traffic here at ThreatX. We take in those API specification files and we highlight the normal traffic that's being used, and we also highlight the suspicious traffic that's being used based on what's compliant to your schema versus what's not compliant to your schema.
And we'll also, one thing that's really interesting with that is we use production data and real API interactions to compute our view of what we think is out there. And so you can sort of compare those two things in our platform of saying, hey, here's an endpoint that didn't show up in the schema that actually is there, and sometimes that can highlight things that you didn't realize were deployed, or that, were on a different version than the schema was generated. And, things that are unexpected can pop out of looking at those kinds of comparing two things and asking what's the difference,
Awesome. Thanks, Austin, for hopping in there. And we are going to answer some final questions that are going to get popped up in our Q&A. So if you do have them, post them there. But some of the final things we want to make sure to take away from this, since we're a little bit over our time, want to be cognizant of everybody's time today, is first and foremost, we're available in person, and we're happy to talk to you online as well. You can visit us very soon at RSA. We're booth number 3205 at the Moscone Center in the South Expo Hall. Myself, Alex, others from our team are going to be there. So please, by all means, stop by and say hi. We did recently support the launch of the definitive guide. This isn't a guide that was written by us, but this was a guide that we felt the need to support because it emphasizes solving problems in the same problem space that is API security. So the definitive guide is also available for download in case you're looking for a new beach read for the summer. The last thing that I also want to emphasize is really with these live Q&As is we're really excited to have people engaging with us online. So we are going to announce a winner for a craft 12-pack of beer that we'll be sending you after the webinar. I think the winner that we drew for today is Miriam Selly. So Miriam, thank you so much for joining and registering. We're excited to have you be our first winner. And we'll be reaching out to you to get you your 12-pack of craft beer from ThreatX. To wrap things up, we do have some final calls or some final questions, guys. I think one of the last ones that we'll probably answer is how long will it take for your solution to identify an attack? Or I'm sorry, what attributes do you track in order to identify an attack?
But I did type up an answer to that one, but so I can just kind of mention. So we really look at everything. We don't just, I would like to stress that we don't just look at layer 7. We actually look at TLS fingerprints. We're looking at like TCP level, like layer 3, layer 4. We're kind of digging in there as well. We're inspecting everything, and we're inspecting it before it gets to you. And that's kind of the key there. That's how we can make these like real-time aggressive decisions.
The reason why it's effective is because we combine a bunch of different viewpoints at a bunch of different levels of the stack. We look at request level stuff, and we look at entity level stuff, and we just sort of try to merge as much information together as we can, and try to find ways that we can separate attack traffic from legitimate traffic and lower that false positive rate, but catch some signal. So it sometimes takes rule definition, and it sometimes takes, oh, we found this very odd quirk of this one application that just picks out the attack and separates it from the attacker. And sometimes it just, is part of the base rules, that the attack just gets picked up. So yeah, but it's many viewpoints that really make it possible.
Awesome. Well, Austin, Alex, thank you so much for letting me and, of course, our audience pick your guys' brain today. I hope everybody found this session to be valuable. We'll be certainly doing more of these live Q&A sessions very soon. Keep your eyes out on the ThreatX website. Any questions we didn't get to today, I'll be typing up in a blog series tomorrow, so you can have some fresh Friday morning reading material to go through to enter the weekend with. But with that, we wanted to conclude today's session by thanking everybody for joining, and keep your eyes out for the next one by following ThreatX. So thanks again.
Thank you, everybody.
Thanks, everyone.